Well, as the title indicates, just going to relay some information about Echolink, IRLP, and then there's a few other uh, similar software and hardware um, out there. And then, kind of along similar lines, there's also some, it's not quite right to say protocols, I suppose, but systems or environments. Um, Things I'm thinking of there are like DMR and things like that. They're also using the internet to do some of these linking things. They're not exactly the same, but there's a relation there. You could say from the standpoint of kind of the background of what they're doing. So just to kind of start out, I kind of put together a little bit of an overview here. And Echolink and IRLP are kind of the two big players in the space there, with, like I said, some smattering of other things also involved, but primarily I'm going to talk about Echolink and a little bit about IRLP, and then we'll touch base on some of these others as well. The bottom part there about revised part 97 is really in relation to this article that I came across while doing some research. And let me see if I can switch that to a little better view. So in February of 2003, so 18 years ago now, this article in QST about voice over IP protocols and amateur radio was put together, and quite a lot of it is still relevant. So I thought maybe I'd just take a minute to kind of show it here. And if you can see the web address, this file is available on the ARRL's website for download. So anybody can just grab a copy and have a look at it if they want to. But they kind of talk about the general overview of what's going on here with these systems and protocols, and a couple of good diagrams of where these links come into play, linking a repeater to a repeater, or maybe a home user has a base radio that they could then interface with the internet and link to a repeater or another simplex node, someone else at their house, etc. So that's kind of a couple of diagrams that are useful to see. And in this article, they go on and they talk about Echolink a little bit. And there's a section where they talk about iLink and EQSO, which, as far as I can tell from researching now, are pretty much not used anymore. The websites that they reference really don't exist and are owned by other people now. So those have really fallen out of favor. And they do talk a little bit about IRLP, and they make reference to Yaesu's system here, Wires 2, which is now kind of end of life and been replaced with a system called Wires X. It's kind of the next successor to that. And they do spend a little bit of time in here talking about remote bases. Well, that might not be the right term, but auxiliary stations, control stations, what it means to be the control operator of some of this equipment in these scenarios. And because this was written in 2003, it's important to note that I think it was 2012 that the FCC regulations were revised there in the past to do some of the control signaling. Say you're using your HT and DTMF tones to control some of these things. In the past, the regulations were that you had to be using 222 megahertz and up. But so much of that happens also in the VHF, 2-meter band with repeaters. The regulations were revised to allow it in the 2-meter band as well. With the caveat that in all areas to stay away from the weak signal, CW, SSB, and satellite portions of the band. So another good resource, the ARRL's band plan, just ARRL.org band plan, and they kind of spell out where some of these portions of the band are. So, stay away from the EME and weak signal portions. So, 144, I think, and away from the satellites, 144.5 and above, for example, or 144.5.10 and above, for example. So if you look at that article, they talk about 222 megahertz, but really it's now also allowed in the 2-meter band. Again, with that caveat that you stay away from the lower end of the band where these weak signal and SSB and CW sections are. So again, the reason I spent a little bit of time in that article, it's a great kind of overview to read into a little bit yourself if something you're a little more interested there. So I laid out a few use cases, but this does not intend to be every single scenario you'd find, but kind of some of the more typical ones. And imagine a repeater, say our repeater, for example, if we were to put an Echolink equipment on it, you could then use that to link to other repeaters. So if you don't have a capability to make the link with an RF path, for example, your repeater you wanted to link to was too far away, or there was some obstruction, then this could be a method to just do repeater to repeater links. You could also use it for, say, a base radio at your house, which you could use to talk into with your HT, kind of on a simplex basis, and then that radio could be used to link to another repeater, for example, if you were too far away to reach it reliably with the radio directly. Echolink also has another mode that's interesting, and that is you can use the computer itself with like a headset, and then your computer can be linked directly to one of these other nodes, for example, a repeater or another person at their house. And in that kind of situation, you might end up not even using a radio at all, which to some folks is, blasphemy in the ham radio world, but it's a feature of the software and a capability there. Some other possibilities are linking multiple systems together. For example, if you had 3 or 4 endpoints that you wanted to all link together in what's called a reflector, kind of like being in a chat room, if you want to think of it that way, or like an audio bridge that you might dial into for a telephone conference. So that would let you connect multiple together and not just point to point. You can also do a user to user. I kind of mentioned that earlier with the computer, and really any other combination of how you want to pipe audio around, with some maybe exceptions depending on the technology you're using. And I made a note there, diagrams, because we'll look at some of those in a second. I always can understand better when I'm looking at a diagram. Excuse me. So with Echolink, the way it started out initially was just a Windows software program, and there's some infrastructure behind the scenes on the internet to make it work as well, but the main piece was this Windows software program. And of course, over the years, it's been updated to include software for Mac and Linux, and there's apps for your smartphones too, so they're available. But what you do is install the software, and then with Echolink, you need to register and validate that you're a ham. And so you would provide, I think when I did this some time ago, I gave them a PDF copy of my license, just to prove that I was a licensed ham. And then they've, marked my account as good, and I was able to use the program. There's a couple of modes if you're using the software in Windows that are kind of delineated here. One is the single user mode, which I talked about a little bit, where you're connected to the computer with for example, your headset, and then on the computer you would connect to connect to like a repeater or something like that. But on your end, you're just using the computer only. You don't have a radio involved. So, an interesting use for something like that might be if you're traveling and out of town and you wanted to check into your local net and your repeater had the Echolink system connected to it. You could, from say your hotel room or a coffee shop, use a headset with your laptop and you could remotely connect to your repeater back home and take part in your net just as if you were normally there. The other kind of mode or operating environment with Echolink is what they call sysop mode. And this is when you have a radio connected to the software. So, for example, in the picture here, you can see we have an FM transceiver connected to the PC, and there would be an interface, and we'll talk about those in a little bit. And then the PC sends that audio through the internet link to the other side. And it might be another radio on the other side. It might be, a person with a headset. And so you might have, the situation where this guy with his headset just connected to his computer and is talking, and, the people on this repeater here wouldn't even know any difference. Well, if I can operate this here. The other thing they mention is the interfacing. And this almost relates a little bit to Ron's presentation last month. The interfacing for Echolink, a lot of them are very simple. You can use a rig blaster, a signal link. You can use a dedicated piece of hardware if you want to. The WB2 REM makes a interface board that gives you a little bit more a better performance, you might say. With some of the interfacing, it uses the signal, your voice audio presence, to trigger the PTT on the radio. So sometimes that can introduce a small delay while that triggers. And so sometimes it is better to use some of these dedicated interfaces. But everybody's setup's a little different, so that takes some experimenting and figuring out what works best for each individual setup. And then I've mentioned here Kenwood, a couple of radios that that have a built-in interface, if you will. They've taken the approach to build that in, and you can just buy a cable from Kenwood to interface to your computer. You can make your own as well, but that was one thing I read, was that they kind of called out specifically these couple of radios from Kenwood. And then the other interesting thing that they talked about with Echolink is a lot of folks, with their home routers, sit behind kind of what they call a NAT environment. And that means that traffic coming in from the internet is effectively blocked unless you were to first make that connection outbound yourself. Well, this can make it difficult for connection on the internet to reach your node locally if it's behind one of these routers or modems that does this kind of thing. So what you sometimes have to do is enable what's called port forwarding, so that the incoming traffic can come to your modem and then be sent inward to your computer behind that and receive that communication. Not everybody has to do that. It depends a lot on your ISP and how it's set up, and it depends a lot on your environment in your home network. But they do call it out, and it's something I did have to do with my setup when I first used Echolink. Well, maybe I should say when I second used Echolink. I used Echolink first many, many years ago, and then never used it for a long time. And then probably about a year ago or so, I installed it on my laptop and started using it again. And when I did that, I did have to do the modem and port forwarding that I mentioned here. So that's kind of an overview of what's involved with getting the software to work. I think we'll talk about IRLP, and then I think a little bit down the road I have some more information about the interfacing. An interesting thing about IRLP, which stands for Internet Radio Linking Project, I believe. What you use there is a PC with a Linux, or you could use something what I would call equivalent to a PC with Linux, would be like a Raspberry Pi device, a single board computer. And then you need to use an interface board that IRLP provides, and that's the picture on the right. And they've taken the approach that everything is going to involve a radio with IRLP, so there is no capability to use your headset with your computer and no radio. Their motto is keeping the radio an amateur radio. And so the IRLP has taken that approach to not necessarily security, if you will, but that's another method to ensure that it's more likely you aren't going to have some random people installing software and getting into your system. If you need to have a ham radio interfaced with this board from IRLP, well, you need to have a license to operate the radio. So they're kind of using that as a bit of a way to ensure that you're an authorized user, of the ham bands. So here's a couple of diagrams of the way the IRLP systems are set up. This information from their documentation. The one on the left is showing how a lot of repeaters are connected to IRLP, and that is through a through a dedicated user radio, I like to call it. This radio depicted here in the top center of the picture really is no different than any other person connecting to the repeater with a handheld or a mobile radio. This radio just happens to be dedicated, connected through the IRLP interface board and through the computer. And so in that situation, like I say, this radio is really the same as any other user trying to use the repeater. I'm sure there's probably some other setups out there where instead of setting aside a separate radio like this, what they do is connect directly to, say, your repeater controller to receive the audio and the squelch line, and to be able to trigger the PTT and send the transmit audio. So I was a little surprised initially when I first saw that this was kind of their default mode. Because I was expecting a little bit more to see the kind of direct connections to the repeater. So I don't know, how many people do this method and how many people, that own a repeater just directly connect it. I suppose one of the biggest benefits to this method is this link radio, if you will, doesn't have to be at the repeater site. So if you didn't have internet connection at the repeater, then this could be a way you could do it. But if you had internet connectivity at the repeater, then it could be, these control lines could be directly connected to the repeater controller, most likely. Then the picture on the right is more of how you might have it set up at as a node at your house, for example. You might have a mobile radio or something like that, a base radio that just is on a simplex frequency. And then with your handheld, you would communicate with that radio. The audio from the base station radio then goes into the IRLP interface board, and then through the computer and out onto the internet. So that would be an example of how you could do that from your house without necessarily having a repeater that was close by to you, for example. This is very similar to how folks use DMR that aren't close to a DMR repeater. They might use a hotspot, what's called a DMR hotspot, for that connection. So that's kind of the overview of IRLP. There was a few others mentioned as I was doing some research on these two. One called All-Star Link, which was kind of interesting. It's a more open approach, I would say. They're very, very different or multiple ways of using the All-Star Link. It's based on some software called Asterisk, which is a PBX is it stands for Private Branch Exchange, but it's a telephone system that can run on a Linux computer, and that's some interesting capabilities there, because with that running on a server as a service, if you will, can sit there and be the recipient of connections from other sources. So, for example, with this Asterisk PBX software running the All-Star Link customizations, you could, in theory, accept connections from an IRLP link if they allowed that, but they don't. You could accept Echolink connections, which there are some folks doing that from what I understand. And you could even accept telephone calls. So, for example, you could have this acting as a conference bridge type situation and have a repeater out there that, say, they would connect to this Asterisk All-Star Link system, and then you could even have, say, 2 or 3 or 4, many other people, if you wanted, who could use telephones to call into this, and you would all be kind of audio conferenced into the same system. So All-Star Link is interesting. I didn't do a whole lot of research about it because it's somewhat different than the other two, although I think all of the capabilities of the other two are there. You would have an interface, directly from, say, your repeater into this Linux software on a Linux computer, and then you could have that doing the linking for you. So there's All-Star Link, which, like I said, is kind of interesting. And then a few years back, Yaesu came out with this Wires 2 and Wires X systems, which are really, it may not quite right to be calling it proprietary, but it's really kind of closed into the Yaesu environment. The Wires X devices really only communicate with other Wires X devices, with exception of, I'm sure there's some folks out there who have kind of hacked together their own interfaces between other things and have, tried to make them work with other things, perhaps Echolink, although I'm not 100% sure if I found any of those examples or not. But so Yaesu Wires X has an interface box which you plug into a Yaesu radio or a Yaesu repeater, and then the Wires X infrastructure does the same thing as the Echolink infrastructure. One Wires X system can connect to other Wires X systems. I mentioned D-Star here a little bit because, while it's different in that D-Star itself is more of a protocol that is used kind of end to end, if you want to think of it that way. You have a a handheld that's got ICOM D-Star capability, and that is digital from the time it leaves your handheld until the time it comes out the other person's radio. And so with the other things I mentioned, they're analog, right? Just like your regular FM repeaters are analog, but the D-Star system is digital. And it's, I mentioned it here because it does use internet linking. You can use RF links just the same in the D-Star system, but it does kind of also use an internet linking system to produce a wide area network, if you will, and has some interesting capabilities too that some of the others don't. Like if you have a 1.2 gigahertz data repeater, there's some high speed, and when I say high speed, it's 128K data capabilities there, which is high speed compared to our 1200 baud packet, but it's not high speed compared to what we're used to with Wi-Fi. But it's quite a bit more throughput than just a packet station would have. So that's an interesting feature of D-Star. Excuse me here while I take another drink. And then lastly, I mentioned DMR because DMR essentially does a very similar thing. It's digital from end to end, and it uses the internet to connect repeaters, but there's also another layer involved, and that's these talk groups that DMR uses. And so the way they're all interconnected through the internet and the DMR infrastructure is very similar to the way some of these others work. With DMR, though, you don't necessarily have to connect to other devices. You just are on the DMR network. So there is some things that aren't similar, but again, it uses that kind of network idea to connect the talk groups and repeaters together behind the scenes. I guess that's really the crux of everything I was going to talk about. Again, very high level, not a lot of detail in, fine detail of how X, Y, or Z works. One thing I was going to do here, I need to find the stop sharing window. And I wanted to take just a minute to call on Jesse, K0WKT. Looks like he did make the meeting tonight. He's involved with a repeater system up in northern Iowa where he's used Echolink to make it go. So I wonder, Jesse, if you might take just a moment to describe a little bit about how that setup works and how you implemented it. Maybe just 5 minutes or so, if you don't mind. You're muted still, so you may need to unmute.
Sure. So I have some experience, probably quite a bit of experience running Echolink. I know my club back home, the Northwest Iowa Amateur Radio Club, they at one point used to have a link for a repeater that ran through Echolink. I believe the way that it was set up was from another ham's house. He had another separate little 2-meter setup that could receive and get to the repeater quite easily. And the actual Echolink equipment, I guess, wasn't at the repeater site. But then again, as Jason mentioned, there are many, many ways that you can play around with it. But that was one thing that my club used to run. I myself have ran a simplex node. Once we got moved out of campus due to coronavirus, I started up a link over at my location, and that was where we hosted our W0 ISU 2-meter nets at the time. So it's not too hard to configure the whole software. For me, the part that I struggled the most was the port forwarding feature. And as Jason mentioned, I guess it depends on your internet service provider, maybe how picky it is going to be to configure that. But after a good day or two of playing around with the router settings, I finally was able to get traffic to connect in into my node. As well, too, I found I've had some issues. I think it was just with my machine at home, my PC, but I've had issues as well with a sound card. I've found, in my experience anyways, that using sound cards that use serial ports, granted there aren't many of those anymore, but sound cards that do have that capability seem to be much more easier to configure. At least that's what I've experienced. Like I said, maybe it's just the kind of machine that I was running that was being picky, but it seems like every time I'd use a Signalink USB, I always have issues configuring it, whereas using a serial port type of sound card, it was quite easier. But yeah, so that's kind of my experience running with Echolink. So turn it back to you, Jason.
All right, thanks, Jesse. Guess that's all I really had, and so at this point, I guess we can take any questions that people have. I notice, Chuck, you've got your hand up in the air there. Do you have a question?
Yes. There used to be, I mean, I'm assuming there still is. I just don't keep up on it. Isn't there, well, on the Alderman Towers, there was either an IRLP or an Echolink node on UHF, if I recollect. Is that still around? Do you know?
Good question. I was thinking maybe I might be able to grab a somewhat recent copy of repeater info. I think a lot of the, the repeater council would usually print out a document and bring to the Hamfest. And I'm just looking real quick to see if I have one somewhat recent.
I think, Chuck, you might be thinking about the 310, 145.310. That one, I think, was an Echolink node. And Brian's got that one currently running Wires X on System Fusion.
Oh, okay.
Yeah, I just found one from a list from 2019 here. And you see there's a few listed. And yeah, it looks like the 310, but it's also listed as Fusion, as Paul mentioned. I'm looking to see if there's any others around. Council Bluffs, it looks like there might be a few. Creston.
Perry's got Echolink running as well. I know that.
Perry. Here's one in Dubuque. Well, I've been around Iowa quite a bit, but I'm not sure I've ever heard of Gillette Grove. Here's one in Grimes.
Oh, what frequency is the one in Grimes on it?
444.725.
Oh, okay.
That one's gone DMR, Jason.
Oh, it has? Okay.
Yeah, that's a DMR machine.
Yeah, so the list I'm looking at is September of 2019, so maybe slightly out of date. Humboldt, Indianola. Paul mentioned Perry, but I haven't got that far down in the list yet. Lamoni. So there's a few around.
Okay.
Minden. You can see there's also some indicated here as IRLP. There's one in Mondamin. I want to say the 10-meter group down in Des Moines, I think, might have had their 10-meter repeater on IRLP. Here's a couple in Ottumwa on Echolink, Perry. Yeah, here's another IRLP in Waterloo. A few Echolinks in Storm Lake, no, Thurman, Washington. So there's a few around.
So what gets me confused is if I want to use IRLP.
Yep.
I either do that from a PC or I set up a simplex station that I can go through, and it in fact is part of the IRLP system. Is that correct?
For IRLP, you pretty much have to get a radio and an interface. They don't, as far as I understand, allow just a PC connection. Echolink does, but not IRLP. And part of that is the way IRLP does some of their, it's not right to say validation, but they're using PGP keys to validate the hardware. I'm not saying that quite correctly, but essentially they're using a PGP infrastructure behind the scenes, and then they validate that your connection from the hardware is allowed. And they've got a whole back-end infrastructure built into the IRLP thing that does like DNS lookups for finding the other links and things like that. So anybody wanting to use IRLP essentially has to buy one of their boards, more or less, and then hook it to a radio of your choice. And then you can use your radio to talk into it.
Yeah. So what was, let's say, on Alleman that was IRLP, I could access it via a radio, and as long as I knew what codes to punch in, I could then route myself to where I wanted to go via their gateway.
Yep.
Right. And then with IRLP also, they have kind of this concept of user codes, if you will. So you would need to also be talking to, say, a repeater owner that had IRLP on their repeater. They would need to inform the user of what codes they might be able to use or not use.
Oh, okay.
As well. Part of their philosophy, I guess.
The VI Amateur Radio Club has all of their repeaters hooked up to IRLP, and I don't know if they're complete on their, according to their website, it looks like they're not totally up and running on Echolink yet. I was just curious what it would take to get there.
Yeah, Echolink seems quite a lot simpler because you can use your own interface, or no interface at all. I mean, you can just use a sound card type connection if you wanted, depending on your circumstance. But I don't know if there's a lot of situations where people have, say, a repeater accessible both ways or not. There's a lot of language on the IRLP FAQs and documentation that talks about that as being a big no-no.
Okay.
Jason, you've got a couple more folks with some questions.
Okie dokie. Gotta figure out how to run this thing. Oh, here we go.
Ted was first, then Skip, and then Jesse.
Okay. I'll rely on Paul's. Go ahead there, Ted.
The point was to follow up on something that Jesse was talking about. Several years ago, I was still with Mediacom and using an ASUS router and had no problems whatsoever with the port forwarding. Very straightforward. More recently, I am now on MetroNet and am using a mesh router and have not been able to figure the problem out yet. I've contacted MetroNet, and they offered for $10 a month to make all my problems go away, but they weren't real convincing that my problems would go away, so I haven't offered the $10 yet.
Yeah, if if you're using a what I would call a common router. Like a lot of people use a Linksys, a certain model, and if it's widely used, it's pretty easy for these projects to put out a little bit of guidance and say, on the Linksys WRT54, it's this setting, and boom, they've hit a lot of people that have that device. But if your router or modem is not one of the more popular ones, then you're unfortunately stuck having to kind of dig through on your own, or tech support at your ISP. But it sounds like they've not been terribly helpful. Or if you know somebody who's in the networking field, they might be able to help you out too.
I might be contacting Jesse.
Everybody's edification is Metronet does run carrier grade NAT. Their solution for $10 a month is a static IP. So that's where that's going with Ted's comment there.
And the main problem with carrier grade NAT is essentially you're double natting, but also you're not in control of the port forwarding. So I have a friend that also has a similar situation. He installed some solar panels, but he's using a Hughes satellite internet to have his connection because he's way out in the boonies, and they also use carrier grade NAT and don't allow incoming connections. So yeah, each situation kind of has to be evaluated on its own there to figure out those problems. Did you say Skip was next?
Yes, Skip was next.
Okay, thank you, Jason.
Yep.
On some of these topics, I stumble over the initials. So I looked up IRLP, and in that case, it was P stood for project. Then I looked up VoIP, and I got a directory of companies that could handle commercial VoIP problems. In that case, the P stands for protocol. Now, protocol generally is some kind of agreed upon process or procedure, and agreed upon by whom? Is there an organizing group behind this, or an association, or was it agreed to by the people on the Internet Radio Linkage Project?
Yeah, that's a good question, Skip. And you've caught me a little bit here. I was hoping to skate by. I've been a little loose with the term VoIP, and not just me, but also the article that was in the QST. And I think in general, when we talk about these kind of things, we just kind of throw around VoIP, voice over internet protocol, and we use it real loosely. And by that, I mean, we tend to use it to refer to sending any kind of audio across the internet. Well, that's not entirely correct. Voice over internet protocol is a well-defined protocol and standard, and set by and administered by the IEEE, Internet Engineering, or IETF, Internet Engineering Task Force. In our conversations about ham radio and using VoIP, we're not really using the term right. We're just using it to indicate we're sending audio across the internet. So to elaborate just a little bit more, you mentioned protocol. And so what that kind of means, or where that comes into play here, IRLP is defining their own protocol and system of communicating behind the scenes between their devices. Authenticating that they're valid devices, them talking to their backend servers, etc., connecting to their reflectors. And that's managed and handled by the folks at IRLP and the volunteers that are running that system. Echolink has a similar group of volunteers that have defined their own standards and protocols and ways that those communicate with each other. Some of them they've defined completely on their own. Some of them they've adopted some open and public standards. One of them related to voice over IP that's commonly talked about is SIP. And that's one that a lot of people have kind of hitched on and just used in the background. But yeah, the way I've used VoIP in this presentation and the way it was used in that article and the way it gets used in conversation is probably not really right. And actually, another thing you can look up if you've got a little more interest, some search terms, voice over IP and ham radio, but also look for ROIP, as in radio over IP, and you'll find another different set of information and interesting links. That also is used a little bit loosely. I'm not sure that there's actually an ROIP protocol, but you have, WiresX, DMR, and all these others using, internet to do that voice linking in the background. Does that make sense, Skip?
If I hit the mute button right, thank you. Yeah, it helps. And personally, I guess I've never used the initials VoIP in a conversation until tonight.
Yeah, you'll hear people say VoIP a lot, talking about it. They might talk about VoIP phones, a telephone that's, plugged into a data connection, and then that's run by a controller in the background, or there might be VoIP service providers. You could get phone service through a cloud-based internet company through your internet connection, not through a phone line, and then you would have a VoIP, either a piece of hardware or software on your computer and use it. So yeah, very widely used term, kind of loosely. Sorry for the the poetic license there. I see another hand raised.
That's Jesse.
Oh, okay. Jesse, did you have another thing you want to add?
Yeah. So something else I wanted to say was when I tinkered around with Echolink as well, another fun thing that I did was I'd have my node up and running, and then with an HT, I'd plug in some DTMF tones, and I could use that to connect to different other nodes remotely, as long as I knew the right combination. And with a couple of friends, we would get on the air locally on 2 meters, and then we'd punch in some DTMF codes, and we could connect to repeaters. For example, down in Australia, I remember one time we did that, and we had a nice QSO with a guy from Australia. So, as well too, Ted, if you're having issues with port forwarding, if you want, I can send you a website that has some detailed instructions about port forwarding. I stumbled upon it probably maybe a year and a half ago, and that was really helpful since it actually provided some instructions for how to do the whole port forwarding thing. It had a ton of different routers there. Now, I'm not sure if for every single router there it had explicit instructions, but for mine it did. So I think if you're struggling with that website might be of use to you. So I can go ahead and send that to you in the email.
Thank you.
Yep.
So I was going to bring up a couple screens here real quick. Let me share my screen one more time. And Jesse mentioned connecting into other systems. And yeah, you can certainly do that and direct like that. Another thing I mentioned was reflectors. If you want to think of it like a chat room. This is IRLP. They have a status page on their website that you can look at and see how many connections there are to these different reflector sites that are out there. And so you can see that, out on the East Coast, they have this particular room has 32 nodes connected to it. Now, you can't really tell if that's repeaters or user nodes, but we might be able to get some more information here by clicking on it. So there is other information out there on the web. Okay, so here's someone from Auckland, New Zealand connected to that, as well as people from Juneau, Alaska, Hooper, Utah, Huntsville, Alabama. So these are all kind of joined into that one channel, if you will. And whenever this person talks, all of these others hear that audio. So that's kind of a little more detail on that. And this is information out here on the IRLP's page. And then Echolink has similar operation, but not quite. But they have these conference servers out there, and a little bit different method of doing it. But they talk about how you multi-conference, etc. So each system has their different ways of doing things, and they're all a lot of different details about how to operate them. So, you know, if you're going to want to get more information on Echolink and learn how to use it on an Echolink repeater to connect to other things, or use it at your, say, home station to connect to other things, definitely go to their website and check their information there, because that's always going to be the most up-to-date information. If they decide to change anything around the way things work, etc., it would be, you know, available there. So at echolink.org, and IRLP is at irlp.net. And I guess if there's no other questions, we can call it done.